Welcome to my Web3 and blockchains series. In today's exercise, we are going to look at how we can create our NFT token using the standard ERC-721 contract. So NFT is Ownable token. I assume you already know what the NFT is, but let me give you a brief overview. It is basically a non-fungible token that is unique and blockchain verify this token digitally. It is basically an asset that can be a digital as well as real world. For example, you have a painting that is in the image format. You can make an NFT of this asset and can bring on the chain. In this exercise, we are going to follow some steps to see how we can create NFT. First of all, we will set up the environment and initialize the project. I have write what I have used to configure my project. For instance, I will be using Hardhat 2.0.2 version. I will be using OpenZeppelin for deploying my contract. I will also use Node to run my NFT locally, and then I will be using Hardhat version 2.17.1. The project will be based on TypeScripts and for storing our asset in the form of image or music or anything that you can represent as a storage media, I will be using Pinata. The version would be 2.1.0 and the dot environment. For the configuration purposes, we will set our tsconfig.json file. We will also set hardhat.config.ts in which we will configure our Solidity version 0.8.30. We will be testing our NFT on localhost as well as Sepolia Testnet. And then we will store our information that is private in the .env. We have done that in our previous exercises as well. So I will just give you a basic overview so you can just follow that step by step and create your own NFT. In the third step, we will create a smart contract. I will name it as my NFT.sol using OpenZeppelin. It will be inherited from ERC-721 standard token that is basically an ownable. It will have a simple private identifier or private counter to keep track of the token IDs. There will be a mapping function that will store our token URI that we will get from our Pinata. We can also use Web3 dot storage as well. There will be mint2 function to mint our contract, and we will deploy it locally using a Hardhat compiler, and then we will integrate with IPFS to upload our asset to Pinata, and then we will get the CID, that is basically the unique hashable address of our asset or storage. We will mint this using mint.ts TypeScript. I will show you how we can write the logic that I have minted, and then we will call the mint2 function from our contract. We will log this hash and token ID for further testing. So for that, we will add my nft.ts in test folder. We will deploy the contract. We will mint the contract and check the token URI and honor of by calling these function. Finally, we will deploy it to Sepolia network. So this is basically simple. I will just give you a recap. So we will create environment, we will set configuration, we will write a smart contract, we will deploy it locally, then we will integrate it with our asset, we will mine it, and we will test this mining, and finally we will deploy it to Sepolia test network. Let's start this. I have created a NFT project. In this NFT project, we will just call those command line in our CMD terminal, and that will create a project for us. Whenever we install Hardhat, you can create a project and it will install the dependency. You don't need to create anything. The packages installation will do it for us, and when we will create a project, so it will create. We have done this in our previous exercises, so you can go back and look at that. I will just tell you how we can add the contract. So I have created my nft.sol contract. It is inheriting from ERC 721 solidity contract. That is basically a standard one, and it is Ownable. We have one variable over here that basically is keeping track of the token ID, unique token IDs, and that there is a mapping of this unique string ID with our URIs. This URI is basically the storage ID, CID of our asset. We have an event over here. We will have a function token URI. This is the getter function. This is the setter function that set the URI to our token URIs array. And then we will have a mint2 function that will be called to mine our NFT token using some of our information from CID hash from hashable CID. So this is my NFT contract. We will add a script deploy.ts that will deploy our NFT contract using ethers, and it will return an address. This is the same as we have done in Remix and in our previous contract deployment using Node. I have write the mint here. Mint.TypeScript will just call the mint2 function from our contract. So what it will do, it will get the signer or the address of the account or the wallet or the person who is the owner. It will get the address from env NFT address. It will fetch the NFT contract, and it will call the mint2 function by passing the address of the signer and asset URI CID. Let's run this. I will start the node in an other terminal. So press enter, and you can see my account is attached. You can see different account and private keys over here. Now let's deploy our contract. So for that we will call npx hardhat run network local host and deploy.ts from our script folder. Press enter. So you can see my NFT deployed to this address. I will copy this address and I will go to my .env. Here place it, I will place it on line number 8. So this is my NFT address. In our previous exercise, I have shown how we can get Sepolia RPC URL private key Etherscan API. In this, I have used Pinata JWT, Pinata API key, and Pinata secret as well. I will show you how you can get these. Just go to pinata.io IO and get it from there by creating your account and paste it over here. We need NFT address. I just compiled and deploy it. Now token URI from where you can get it. I will show you how you can get. You need to create an asset folder, put your image, your uh, music or anything that you can represent a digital asset over here, and we will deploy this in our IPFS step. So my contract has been deployed locally. Let's follow the step of minting now. So we will call npx hardhat run network localhost script mint.ts. So we will just call mint.ts. I will press enter and you can see minting with account. This is the account connected to contract. This is our contract that we just deployed, and it has been minted hash at this address, and it has two block, which means our asset has been minted. We have created NFT locally. Now let's deploy this in our Sepolia test network. So let me tell you one more thing over here. In your packages, in your hardhat.config.ts, you can see you have defined your localhost and your Spolia over here. So this will be picked by our command line terminal. So when we run npx hardhat run dash dash network sepolia, so it brings the information from our hardhat configuration and then it will deploy the ts. Let's deploy this. Here we have deployed our contract on sepolia network. You can verify this deployed NFT on etherscan.io as well. So let's verify. So I will just copy and paste my address over here, press enter, scroll down, and you can see this is my NFT contract that has been deployed over Spolia Ethernet network that has been deployed on our Sepolia Ethereum network. So this is my Solidity contract. So it's an Ownable. You can connect it with your wallet as well. So click on read contract, connect with Web3. I will connect it with my MetaMask. So you can see this NFT token has been connected with my wallet. I can also write, I can also give the right permission to my wallet as well by connecting it with my wallet. So let's connect to like this way. So we have created our own NFT token. I will show you how you can get CID from Pinata. So go to Pinata and log in or sign up. So you will come up on this dashboard. So you can just click on add file upload. Whenever you will upload the file, it will be come up over here. So it will generate a CID. So just copy this CID and use it in your .env token URI IPFS. So this will be your CID that you will get from Pinata. I will share this code with you so you can go through this quickly. You can make changes. If you have any question, just drop a message. I will respond over there. Thank you.